Hello friends, welcome to our channel. Today I will discuss regarding on arithmetic shift micro operation. Last lectures I explained that is logical shift micro operation. Now today I will discuss regarding on arithmetic micro operation. Okay, so let us start. Let us consider that is a any bit data, doesn't matter, as you like. We can take 4 bit or that is 8 bit, doesn't matter. Let us consider 8 bit. 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8. Okay, when it will shift, then result will also store 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8. Okay, and whenever you go through any data, as you like, your choice, we can take any data. Okay, this data we can consider LSB. I have already explained in the last lectures for this shift operation, and this one also there is MSB, most significant bits. Means left hand side we write most significant bit, and the right hand side we can tell as a least significant bit. Okay, most significant bits and least significant bits. Okay, as you like, any data we can consider, doesn't matter, as you like. So now we see, whenever let us consider, first of all we consider the data like suppose 1 1 1 0 0 1 0 1, for example, as you like. Before discussing this arithmetic micro operation, shift micro operation, what happens? We have already know that is a logical shift operation. Logical shift operation is a very simple way we can consider. But if we go through arithmetic or arithmetic shift micro operation, the role of this micro operation is important. When any bits we consider it defined through MSB bit. That means the MSB bit is considered as it is a positive or negative. Okay, if positive or negative. If it is or sign bit, we can write also sign bit or unsigned bit. That is depend on that. If it is 1, very simple way. If MSB bit is 1, then what happens? It is considered as a sign bit. You see here MSB. If MSB, okay, if MSB is 1, it consider as sign bit. Okay, in that case what will do, or other case what will do? If it is sign bit, whenever a shift operation applied, left to right or right to left, sign bit never will change. Okay, sign bit never will change whenever applied. So sign bit as usual we can take it. After that is some operation left to right or right to left we will consider. Okay, so now we will start how we will consider for that is a arithmetic shift operation, right? Arithmetic starting from right shift. Okay, starting from right shift. Suppose we consider here arithmetic, here we can write arithmetic right shift. Okay, right shift. So here one plus point or one technique we apply, then you can use how it is consider. Since it is a 1, I told that if MSB 1, it considers as sign bit. If it is 0, unsigned. Okay, sign means that is a negative number. It is considered as a negative number. If a sign bit means it is considered as a negative number. Okay, this is the concept. If it is 0, no negative, positive number. So since it is a negative number, then the particular approach or technique we apply. How? Since this is a negative number, means whole bits are total number will be negative number. Negative is negative. We can consider as a positive. And which case consider positive or negative, that you will see. Okay, but it is a negative number. In that case, what happens? This particular negative numbers or that is a sign bit, since 1, as it is we consider 1 as it is, because since this is a sign bit, all numbers will consider as a negative number, since it is a MSB is 1. So whenever we will shift, so all data will be shift through that is negative number. So what happens, we consider this 1 as 1 here, so remaining part is negative, means this total number will be negative. Then what happens, again it copy, since 1, again this 1 is copied to next number. Okay, this copy to next number, that means as it is here, same we write, again this one copy to here, or we can write like this. Okay, in this way. Next what happens, in this way, this is 1, this is remaining part shift right accordingly, no problem. 1, it will be 0, it will be 0, it will be 1, it will be 0. Okay, once again, 1 as it is 1, we can take it, copy of that 1 we will consider again, or directly we can transfer from here to here. Okay, as it is, as your choice, because it is 1, so we have to make it 1, again 1 will be copy from here to here, or directly we go through this one. Remaining part, that is transfer from left to right, since it is a right shift. You see, last up to here we get this one, but what about this one? This one will be discarded, since there is no space for this number, this can be discarded or rejected. Okay, or rejected. Now this data we can add, so we can consider in this way. If that is again we shift, for example, again we shift towards the right, means left to right, then what happens, same thing we can consider very simple way. One time it consider in this way, second time you will see what is the data value, 1 2 3 4 5 6 7 1 2 3 4 5 6 7 8. Similarly, you see very simple way, here 1 as it is 1, and a copy, I told that is copy, or the same 1 you will consider here 1, here it is 1, here it will be 1, here will be 1, this one, here will be 1, here will be 0, here will be 0, here will be 1. So it will be discarded. Okay, it will be discarded. So in this way, so we can get number of that is data or number of shift from that is left to right as our choice, whenever which shift operation need to operate. Okay, this is the one thing, this is the arithmetic right shift. If we go through another concept like arithmetic, this is the one part is over. Okay, next part, it is one part, first part, second part similarly we can write arithmetic left shift. Okay, arithmetic left shift, that means what happens, if we go through that, then you see how it is working, left to right. Okay, sorry, left shift means right to left, how it is working. Okay, here you see very simple way, 8 bit suppose we consider 1 2 3 4 5 6 7 8. Okay, we will consider for example, then you see as you like, your choice, we can take it, doesn't matter. Suppose we consider that is 0 1 1 0 0 1 1 0 for example. Okay, now you shift this one 1 2 3 4 5 6 7 8. Okay, now see, now transfer from what, right to left, since it's a left shift, transfer from right to left. If we transfer from right to left, then what happens? Here very simple, here is 0, here is 1, here is 1, here is 0, here will be 0, here will be 1, here will be 1, here will be 1. Okay, 1 1 0 0 1 1 0. So what happens, you see, this will be discarded because there is no space to shift this 0 to this bits number. So it will be rejected, okay, rejected or discarded, we can consider. But here you see some space is vacant here. In that case what happens, since it is vacant, we add this vacant space here. Okay, that is a 0. 0 we can add here. So now that is the arithmetic left shift is over. So any kind of a bit operation we will consider either that is a right shift or left shift, we will consider as it is, doesn't matter. It is very easy. If we go through, only the concept is, if we go through this arithmetic operation for that is the right shift, then we check that MSB is 1 or 0. If 1, we have to check that same and shift after that. If it is 0, no problem, same 0 also we can put, because it is 1 for sign bit, 0 for unsigned bit, doesn't matter, same thing you can consider, doesn't matter. But we have checked that it is a 1 or 0, only that's all. Okay, and other part arithmetic left shift if we consider, then what happens, it is normally as logical shift operation, whenever you consider, similar concept also we can consider here. Okay, there is no problem. In this way we can consider that is a what arithmetic left shift. Okay, sometimes what happens, sometimes this concept sometimes there is a create some problem, because you see here is a 0, that means a positive number, but here will be 1 sign bit means a negative number. Okay, here positive negative, that means it is a overflow condition will occur. In that case, okay, in that case we have to consider one kind of XOR data on this particular last these 2 digit. Okay, XOR data on this particular digit, we see that how it will determine last 2 bits, means MSB and previous to MSB. These 2 data we can define through XOR gate. Okay, that XOR gate, suppose let us consider XOR gate output X. Okay, anything XOR gate, any determine suppose V, one kind of a result suppose on this 2 XOR gate of 2. Okay, then that V will see this 2V or V, how it is determined. This V is determined by E is equal to R n minus 1 and XOR gate with the R n minus 2. You see this is a R, okay, R n minus 1, this is a R n minus, sorry, this is minus 2, this is R n minus 1, for example, because last 2 we consider, since starting from here 0 to like this. If this V value, whenever consider this one, if V value is 0, okay, if V value is 0, there is no overflow. You see that, no overflow, no overflow. Okay, if it is V is 1, if V is 1, then overflow condition will be applied. Overflow condition will be applied. Okay, in this way we will see that how in this case we don't consider. Next that is lecture, I will consider how it will be overflow. If suppose overflow condition will occur. Okay. So thank you very much. And another concept is also there, since it is a arithmetic shift micro operation. Is that is I explained last lecture. I explained logical shift micro operation. Now I explained arithmetic shift micro operation. But here question is, sometimes not sometimes, every time whenever a shift from left to right or right to left, one data, either left hand side or right hand side data, will be discarded or that is rejected. So that is the disadvantage of this shift micro operation. Okay, that disadvantage or that is limitation of that shift micro operation. To avoid such kind of limitation, we also consider that is another way how that discarded or rejected data again reuse into the shift operation. That is I will tell you next lectures. Okay, how that is reused of rejected or discarded data. Whenever that rejected or discarded data reuse, you can tell or we can call those shift operation like a circular shift operation. That another concept is there, that is a circular shift operation, and where there is no rejected or the loss of data or there is any gain of data. That is every data that it can be reused in such way that by which we can tell as it is a circular shift micro operations. And I will tell you next class this is regarding on this circular micro operation, shift micro operations. Okay, thank you very much. Thanks to all to watch these videos. Please subscribe my channel, and all of you there is a progress this all of you with the help of you I progress this channel. Thank you very much, and please subscribe my channel. And if you want to give some comments on these videos to improve these videos or progress this channel, please comment to me. I will I will check that how it is possible to progress and improve these videos and also channel. Okay, thanks to all. Thanks.